biology students, this is Bikini Bottom Genetics with Ms. Schimmel. These are the dihybrid crosses. We're going to do 1, 2, and 3 all at once. Heterozygous for round eyes, that would be a capital and a lowercase letter or 2 different alphabet letters. In this case, we're just talking about classical Mendelian genetics. So for 1, 2, and 3, we're just going to use the chart over here to get our answers. Remember, on a dihybrid cross, you're looking at 2 traits at the same time. For number 1, you're heterozygous for round nose, so capital R, lowercase, and a blue body is recessive, so that has to be written as little y, little y. Hybrid eye shape for number 2 has to be capital R, lowercase r, just like number 1, but round pants this time is the recessive trait. Square pants is dominant. That would be a capital S. In this case, you can only be purebred for round pants if you literally are recessive round pants. So number 2 is big R, small r, little s, little s. If you're purebred for round pants, again, you're little s, but if you're heterozygous for the long nose, you have the long nose gene, and you also have the short nose gene. So you are big L, small l. SpongeBob's aunt, who is round pants, has a cute stubby nose, blah, 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 blah. Identify the aunt as round pants. She is round pants, so that is little s, and she also has a stubby nose, which is recessive, so she's little l, little l. Purebred for square pants, on the other hand, for the fiancé, is big, and a long nose is also big. If they were to do gametogenesis, spermatogenesis, oogenesis, what's the only thing they can pass on in the egg and in the sperm? For the aunt, she can only pass on the little s and the little l. The fiancé can pass on the big S and the big L. Do you really need to have a Punnett square, a big block that shows all 16 of these? Do you need to do that? I don't think so. What happens if this egg right here and this sperm right here get together? You're going to get big, little, big, little. That's all. What's the possible genotypes for their children? Big S, big L, little l. So what are they going to look like? They're going to be square pants with a long nose. That's all. So SpongeBob is heterozygous for his yellow body. He gets a big Y, little y. He's also heterozygous for his square pants, big S, little s. Sponge Susie, on the other hand, is blue, little y, and round pants, little s, s. If SpongeBob were to go through the process of gametogenesis, meiosis, making his sperm in the process of spermatogenesis, he could pass on the big Y, big S. We'll put it down here on the Punnett square. Or he could pass on big Y, little s, big Y, little s. He could also pass on the little y with the big S, little y, big S, or he could pass on even the little y with the little s, little y, little s. Since Sponge Susie is only little y, little s, the only gamete combination when she does meiosis, oogenesis, making her eggs, she can only pass on the little y and the little s. I could repeat that down here on the Punnett square 4 times, but I don't really have to because she's only going to make this one special type of egg. She gets the little y, the little s, the little y, the little s, the little y, the little s. So what does SpongeBob pass down? He can pass down the big, small. This one's a small, big, and this one is a small, small. So as you have it, there are going to be 4 children possible, but this one looks big, square. So it's going to be yellow and square pants. This one is also yellow, but since we have 2 small s's, it's going to be round pants. This one instead here is going to be it's going to be blue. He's a blue one, but he has the square pants like his dad. And lastly, this one is going to have blue skin, like Mama. It's a blue sponge, and she is also going to make this one a round pants, just like her. That's 4 children possible. You could repeat that again if it really wanted to, but you don't really have to do the full Punnett square. You don't need all 16 boxes filled, do you? If you keep that chart in mind from up above, you would be able to see the chances of being a blue baby are 2 out of 4, 50%. What is the chance of being both blue and square pants? This one is only 1 out of 4, 25%. What is the chance of square pants? Again, 2 out of 4, 50%. But what is the chance of being purebred recessive for both traits? That's where SpongeBob's recessive genes would have gotten together with her recessive egg. Well, that's all she can pass on, but that's only going to happen 1 out of 4 times for the Punnett square up above. You could do a Punnett square for number 6 if you really want to, but you don't have to. It's asking what is Patty's phenotype. Well, her phenotype is her physical appearance. You know that she is recessive for both traits. What traits are we talking about? We're talking about pink versus orange. She's orange. And we're talking about thick versus thin eyebrows. So in this case, we know that Patty, who is recessive, has to be little p, little p, little t, little t. She's an orange, thin, eyebrowed chick. So we know that Patty is orange with thin eyebrows. What about Patrick Starfish? He is pink, but he's heterozygous. So he's big P, little p. And he is homozygous for his thick eyebrows. The question here asks you, would it be possible for their offspring, Patty and Patrick, if they started with an orange mama with thin eyebrows, if she gets together with Patrick, who is homozygous? In this case, no. Could they have offspring that are orange with thin eyebrows? No way, Jose, because Patrick will always pass on at least one of his big T's. So they might end up being orange. They could be little p, but they always have to have at least one big T to give them thick eyebrows. Orange, thin mom. Pink, thick father. Before Patrick commits to his relationship, he would like to guarantee that his offspring would have his thick eyebrows. Should he get married? Yes. That's what you just said for part B. So he can only pass on the big T gene to his offspring, so all of his offspring will have thick eyebrows just like he does. Get married. Did you see this down here saying about blue and green hair and bald? Take a look. Do you know Squidward's genotype? He is homozygous for his blue skin, but he's also bald. He's big, small. Squidward is homozygous for his blue trait, but he's also bald. Must she have hair if he wants children to have hair? Yes, she must have hair. She must have at least one capital H. She could be heterozygous, but his chances are finding a homozygous bride. Must she also be blue? No, she doesn't have to be blue for this one, because he can pass on his big blue gene or his big blue gene. All of his kids will automatically be blue. I apologize because my crayon is not letting me write in the proper place at this time. But must she be blue? She does not have to be blue because Squidward is homozygous dominant. The only thing he can pass on in his sperm would be the big blue gene. So she can be blue or not. It doesn't make any difference. What really matters is if she is homozygous or heterozygous for having hair. She can't be bald like him. So Squidward has found a potential bride. Octavia has hair, but her father does not. So what are their chances of their children being blue and having hair? She's heterozygous for that trait. Sorry for this being on the page break. We know that Squidward is homozygous for his blue, and he's bald. Octavia is green, but she has a father without hair, so she must be heterozygous for her trait. Let's put their genotypes for their egg and sperm down below. Remember that Squidward is big, small. So we're going to put the big and the small here. That's all the more that he can pass on. She, on the other hand, is little b, big H, little h. So she can pass on the little b with the big H, or she could pass on the little b with the little h. What are the chances of them having offspring that way? Big, small, big, small, big, small, small. Let's answer the questions. If you want to do this full Punnett square, you're welcome to. You could fill in big B, little h, big B, little h, big B, little h, and you could carry these down the line, little b, big H, big H, but you don't have to do that. Same thing for here, same thing for here. So if we look at the 2 babies that were created from these two parents, we have a 50-50 chance. What are their chances of their children being purebred for their offspring? Well, only this one child is purebred for the bald gene. Right there is one bald child. That's it, 1 out of 2. What's the probability of their children being heterozygous for both traits? 1 out of 2 total. So it's a 50% chance. As a reminder, homozygous means 2 of the same. Heterozygous means 2 different. Those could be different alphabet letters or different sizes, like capital, lowercase. Here's the answer to part 1. Part 1, AA is homozygous, OO, homozygous, BO is heterozygous, hybrid. Big B is homozygous, AB. Those are heterozygous also, and AO is heterozygous. So which are purebreds? Any of the ones that are homozygous up above. You may have just written ho. For the ones that are hybrid, it would be like BO. Not that you stink, but those are different alphabet letters. Same thing with AB or AO. Those are all heterozygous mixed. Are you okay doing part 2 and part 3 on your own? Take a moment. If you have AA as your genotype, your phenotype would be blood type A. If you're AO, again, you have blood type A. OO is doubly recessive. You only have the O blood type. Big B gives you B type blood. BO, you don't stink. You have B type blood. And if you're AB, A and B are co-dominant. They're equally important. So you have AB blood. For the blood type, for the phenotype, the way that you look, what are the genotypes? Well, if you're blood type A or B, you could be homozygous for the trait or heterozygous. So type A is either AA, homozygous, AO, heterozygous. Same thing with B. B type blood is either homozygous, BB, or heterozygous, BO. O must be recessive, O must be homozygous. AB is codominant, AB. Sandy Squirrel met Stuart Squirrel. She is AB, so let's put her genotype up top. And let's put Stuart's over on the side, OO. They end up with an AO, they end up with an AO, they end up with BO, BO. So, what are the possibilities of a squirrel with type O blood? 0 out of 4, or 0%. There's also 0 out of 4, or 0% chance for AB blood. However, there are 2 children and 2 children that end up with the AO and BO. So that is 2 out of 4, or 50%, that are blood type A, and there's also 2 out of 4, or 50%, that end up being blood type B from this Punnett square. For the next one, Mr. Krabs' genotype, since he's homozygous for A, is AA. Mrs. Krabs is BO since she's heterozygous. If they have offspring, they would end up with 2 out of 4, 2 out of 4. How many are O-type blood? 0. How many are AB? 2 out of 4, 50%. How many are blood type A? 2 out of 4, 50%. There's no chance of being blood type B. No. For part 1 here, don't forget to read the instructions and the little remember. What's a carrier? How do you know if they have the trait or not? What makes a male, a female, a female? I'm going to fill in the chart here. Can you see the females versus the males? We're looking for the recessives to see if they have the trait or not. No, yes, no, no, yes. Typically, the definition of a carrier is someone who can pass the trait on but doesn't themselves have it. So this last male here, he is X little ky. It's a male. He will show the trait because he's recessive, but he's not really a carrier in a sense. This is not a carrier, not a carrier, not a carrier. See that little recessive letter? She can pass that on to her daughter or to her son. Sex-linked traits are only carried on the sex chromosomes, like here, here, and here. That's all. I'm going to run out of time for this recording. I'm so sorry. How can a female inherit color blindness? Both of her parents has to pass on the recessive genes. Mom doesn't have to be colorblind, but she could be. But she, as a mother, has to have at least one bad X that she passes on to her daughter. Fathers don't pass on sex-linked traits to their sons. Why not? Why? Because the dad passes the Y to make the boy the son. Under what conditions is it possible for both a father and his son to have hemophilia? Both of their mothers were either carriers or had hemophilia, just like color blindness, or even male pattern baldness. Why are females able to have a better